All right, we're back at it. Welcome to Warm-Up 13. This will be the last online lesson. First of all, it wants me to find the slope at x equals 2. Well, we remember that the derivative is the slope. So it's simply asking me to evaluate f prime at 2. So that's going to be 4 minus 9 over 4 plus 2. So it's going to be negative 5 over 6. Then it wants the normal line. Well, the normal line, remember that that's perpendicular to the tangent. So this would be the slope of the tangent line. So my slope has got to be positive 6 over 5. So my normal line is going to be y minus 3 equals 6 over 5 x minus 2. And just remember, pay attention to when it's asking for tangent line and when it's asking for normal line. Okay, the next question is, does the derivative exist everywhere? Well, I look at the derivative and I ask myself, are there any domain restrictions for that derivative? Well, normally a domain restriction would be taking the square root of a negative number or trying to divide by 0. So since there's no way it can't equal 0 because x squared can't equal a negative number, so it will exist everywhere. Okay, and the x location only of the horizontal tangents. Well, the horizontal tangents are, if you remember from the graphic earlier this week, horizontal tangents occur when their derivative equals 0. So that's m equals 0. So 0 equals x squared minus 9 over x squared plus 2. So I'm going to turn that into 0 over 1. I'm going to cross multiply, and I end up with just x squared minus 9 is equal to 0 when I cross multiply. So x at plus or minus 3. So that's where my horizontal tangents. I'm going to make a little side note because sometimes I ask the x location only, which is where all I have to do is divide or set the denominator equal to 0. But it is possible, let's see, it is possible that I ask for a location. Of horizontal tangent. Okay, and the way that works is you will find where the derivative equals 0 and then find the x value. Okay, so you're going to find the x value where the derivative equals 0 and then substitute those values into f of x, not into f prime of x. Okay, that because we're asking a location question, that means you use your original function. We don't know what the original function was here. We'd have to take the antiderivative. We have no idea how to do that yet. So I don't give you enough information to do that on this problem. But be watching for that because if it asks for coordinates, so if I ask for the location or coordinates, that's what you have to do. All right. Believe I have in here in my notes to go over a problem. I think it was a homework problem. I'm going to go ahead and throw it in these notes because I'm assuming it's in here because people were having trouble with it. So I'm going to go ahead and do that particular problem also. And that was the limit as h approaches 0 of tan 3 pi over 4 plus h plus 1 over h. And then I'm going to recognize this as a derivative in disguise. That's limit as h goes to 0 of f of x So right, f of x plus h minus f of x over h. The thing is instead of x, I have 3/4, 3/4 of a pi. And what that means is that this is the derivative at a specific point. So what I need to do is figure out what my original function is. Well, I'm suspicious that it's tan, so I'm going to go ahead and rewrite this. Limit as h goes to 0 of the tangent of 3 pi over 4 plus h plus tan of 3 pi over 4 over h. Well, tan of 3 pi over 4 is -1. Okay, and we know that this is supposed to be a negative, so that's why the +1 is there. Okay, so really what I'm asking for is I'm saying my function is tan x, and I want the derivative of that function at the value of 3 pi over 4. Okay, so the derivative of tangent x is secant squared x, and then at 3 pi over 4, my cosine, which is 1 over cosine squared x, and at 3 pi, cosine of 3 pi over 4 is square root 2 over 2. So that's 1 over square root 2 over 2 squared, which is going to be 1 over 2 over 4, which is going to simplify. Sorry, that's a negative. That's a negative. That's going to simplify to be 2. All right, so we're going to go on. We're going to finish the examples on those sheets. So my derivative of cosecant, which is my outside, is cosecant cotan, and it's negative because it's a negative tan function, negative trig function, trig function that starts with c. So this is going to be negative cosecant of sine x cotan sine x times the derivative of the inside, which is cosine x. So that is acceptable as a final answer. Okay, notice that this is different. The last one had the cosine x, the sine x in the bubble with the cosecant. This is just product rule. Let's try writing that a little more neatly. So that is going to be the first times the derivative of the second. Sorry, the derivative of the second, which is cosine x, plus the second times the derivative of the first, which is okay, and hopefully you see this coming, that this is going to be 1 over sine x. You're going to have to be doing some trig simplification. Sine x times 1 over sine x times cosine x over sine x. So this ends up being cosine x over sine x plus sine x divided by sine x. And then this is going to be, forgot that that was a negative cosine x over sine x. So that ends up being 0. All that work for 0. Now, I could have saved myself a little bit of time and hassle if I had just recognized that I could simplify that function in the first place. Cosecant x sine x, there's nothing saying I can't simplify that first. That's 1 over sine x times sine x, which is 1, and the derivative of 1 is 0.